Hey students, in this video lecture we will be discussing about the fundamental theorem of arithmetic and we will be solving few questions based on it. So what is the fundamental arithmetic theorem? It states that every composite number can be expressed or factorized as the product of primes, and this factorization is unique apart from the order in which the prime factors occur. Okay, I'll take some example. Okay, so it's given that every composite number can be expressed. So what are composite number? I take the example as 6. Firstly, the composite numbers are those numbers which has 2 or more than 2 factors. Okay, the composite number are those numbers which has 2 or more than 2 factors. Now, taking 6 as an example, the factors of 6 are 1, 2, 3 and the number 6 itself. So definitely 6 is a composite number because here the number of factors are 4. We have 4 factors for 6. So this is a composite number because number of factors should be more than 2 or 2. Okay. So if we factorize 6, what can we get? We can get these as the factors. Okay. So it is given that every composite number that we have taken here 6 as an example can be expressed or factorized as the product of primes. It can be expressed as the product of primes. So what are the prime numbers over here? That is 2 into 3. We can write it as 2 into 3 or 3 into 2. Here both 2 and 3 are prime numbers. Okay, and this factorization is unique. This factorization, either you consider this one or this one, this factorization is unique apart from the order in which the prime factors occur. Means regardless that you write it as 2 into 3, you write 2 in front and or 3 at back or 3 in front or 2 at back, it doesn't matter. The factors are 2 and 3. Here also the factors are 2 and 3 only. So apart from the order, means regardless whatever order you take, the factors are unique, the product of the primes, and this factorization is unique. This is what this fundamental theorem of arithmetic states. Okay, so now let's move on to the next question. Consider the number 4 to the power n. Okay, I have considered some number 4 to the power n. N is a natural number, where n is a natural number means this n is here is some natural number. Check whether there is any value for n for which 4 to the power ends with digit 0. Okay. So 4 can be written as 2 square, right? We can write this 4 as 2 square, and since this is 4 to the power n, so we can write it here as n. Okay, so we wrote it here like this. 4 is written as 2 square and it's 2 square to the power n since it was 4 to the power n. Okay, so this is again equivalent to 2 to the power 2n. Okay, these two gets multiplied and we can write it like this. Okay, now here we have to check that for any value of n, whether the digits end with 0 or not. Now if the digit would end with 0, it should be divisible by 5, right? Like digits ending with 0 like 10, 20, 30 or 40 or any number like 1000 or 10,000 or 500. All these numbers are divisible by 5. We know this very well, right? Okay. So for any number, for its digits to end with 0, it should be divisible by 5. So for this to happen, this prime factorization of 4 to the power n should contain 5. For ending the number, for that number to be divisible by 5, and 5 is since a prime factor, so the prime factorization of 4 to the power n should contain 5. But we noticed that the prime factorization of 4 to the power n contains only 2. See, it contains only 2 and nothing else than 2, nothing other than 2. So the only prime factor that is contained in this 4 to the power n is 2. And 5 is not possible. So the answer is no. There is no value of n for which 4 to the power n ends with digit 0. For we don't have any value of n for which this 4 to the power n can end with a digit 0. Okay, so in our next question, what we need to do? Find the LCM and HCF. You need to find the LCM and HCF of the numbers 6 and 2 by prime factorization method. So here you need to find by prime factorization method. So the first number is 6 and the second number is 20. We need to find once the LCM of 6 and 20. We will find it out, and the next time we will find out the HCF of 6 and 20. Okay, and the method is also given, that by which method you will find it out. You will find it out by prime factorization method. Okay, so let's find out the prime factors first. Okay, so how we will find the prime factors? You have learned this in your junior classes as well. 6. So how will you divide? Like we know, 2, 3 are 6. Okay, and 3, we got it like this. Okay, this cannot be factorized any further. Similarly, we can do it for 20. 2, 10 are 20, and 2, 5 are 10, 5 1s are 5. Okay, so you can write it here as 6 is equals to, this 6 is equals to 2 into 3 into 3, and this 20 is equals to 2 into 2 into 5, right? Okay, 2 into 2 into 5. And the best practice would be if you write here 1 also, if you consider 1 also. So here write 1, here also write 1. This should be the best practice if you consider 1 and write it in your prime factors also. Okay, now we need to find the LCM and HCF. So for HCF, we will have to find the highest common factors. These are the factors. Now we need to find out the highest common factor. What is the highest common factor among both the numbers? 2. Common factors are 2 and 1. So among them, 2 is the highest. So the HCF of both the numbers are 2. The highest common factor is 2. Now we need to find out the LCM. For considering the LCM, now what you will do for writing the LCM, that is, for these two, you will write 1, 2 only. Okay. For now there is 3 and 1, 2. So 3 and 2 you write it down. Now there is 5 as well. And for these two 1, you will write a single one. So what you got? 2 into 3, 6. 6 into 2, 12. And 12 into 5, 60. 60 into 1, 60. So the LCM is 60 and the HCF is 2. This is the answer. Okay. So our next question is, find the HCF of 96 and 404. We'll need to find out the HCF of these two numbers by prime factorization method and hence find their LCM. Okay. We'll try this question also. Now, we have to find first the HCF of 96 and 404. And after finding out the HCF, we will also find out the LCM of these two numbers. Okay, we will do that out. First, let's find out the prime factors. So for finding out the prime factors, let's perform the prime factorization method. So beginning with the 2, the smallest prime factor, 2 4s are 8, 2 8s are 16, 2 2s are 4, 2 4s are 8, 12, 2 12s are 24, 2 6s are 12, 2 3s are 6. Performing the same way for 404, 2 202, 2 101. And now this 101 is no more divisible. So you can write it here as 101, 1 ja 101. Here you can write it as 3 1 ja 3. So here we can write 96 is equals to 2 to the power 1, 2, 3, 4, 5. Right? Here you can write it as 2 to the power 5 into 3 into 1. Okay. And 404 is equals to 2 to the power 1, 2 into 101 into 1. So first we will find out the HCF. So the highest common factor between these two are what are the first we'll find out the common factors. 3 is not common between them. 101 is also not common between them. So the common thing that we have between both of them is 1 and 2. So the highest common factor is 2 to the power square. So you can write it as, you can take here 2 as well common. So how we will write? If we take out, we can take, here we have 2 to the power 5. So we can easily take 2 square common from this. So the highest common factor is 2 square, that is equals to 4. Okay. Now comes the main formula. And that is that HCF into LCM is equals to the product of the numbers. This is a formula, that HCF into LCM is always equals to the product of the numbers. Now we got the HCF. What we got for HCF? We got the value of HCF as 4. So 4 into LCM will be equals to 96 into 404. So LCM will be equals to LCM will be equals to 96 into 404 by 4, cancelling them out, 101, which will give you the result as 9696. So we got the value of LCM as 9696. So the LCM of 96 and 404 will be equals to 9696. Okay. Now let's move on to the next question. Find the HCF and LCM of 6, 72 and 120 using prime factorization method. You'll have to find out the HCF and LCM of 3 numbers. Okay, let's do it by prime factorization method again. So let's do it first for 6. Sorry. 2, 6 are 12, 0. 2, 3 are 6, 0. 2, 15 are 30. And for 15, we can write it as 3 5s are 15. And now 5 1s are 5. Now, how you can write it now? That 6 is equals to 2 into 3 into 1. 72 is equals to 2 to the power 1, 2, 3 into 3 to the power 1, 2 into 1. Okay. And 120 is equals to 2 to the power 1, 2, 3 into 3 into 5 into 1. Okay. So first we need to find out the HCF of these 3 numbers. So HCF of 6, 72 and 120 will be equals to, we need to find that out, and we also need to find it out the LCM of 6, 72 and 120. Okay, so the HCF of all these numbers will be equal to, see what are the things that you can take it out in common. 2, a single 2 can be taken out. Okay, so 2 is taken out. Next, what is the next other thing that you can take out? A single 3 can be taken out. Single 3. Can 5 be taken out? No, because 5 is not present over here and not here. 1 can again be taken out, but considering 1 is like the same only. Okay. So the HCF will be equals to 6, right? 2 into 3 into 1 will give you 6. So the HCF of 6, 72 and 120 is 6. Now we will find out the LCM. Now again we got the formula as we solved in the previous question, that LCM into HCF is equals to LCM into HCF is equals to product of numbers, and the numbers here are 6, 72 and 120. Okay, so as per the previous solution that we did, here we will easily get the LCM by putting the value of HCF as 6 and cancelling them out. But is it true? No, students, keep this in your mind that as you have 3 numbers over here, so the product of LCM and HCF is equals to the product of any two numbers, means the particular those two numbers only. You can find it out when you have been given the two numbers, but in this case we have been given three numbers, so we cannot find out the by this formula. Okay, we cannot find out the LCM by this formula, so this would be wrong. So the correct method to find out is how? What we will do right now, we need to find out the LCM, right? So the LCM will be equals to, now the common factors we will find it out, that 1 2 we can write it over here into. Achha. Now what else we can take out? 1 2 is taken common from all these, and 2 square still remains there. Next, you can take 1 3 from here, and one more 3 remains, so you can write it as 3 square, and 1 5, and 1 can also be taken out as common. This will give you the value as 360. So this is equals to 360. Okay, so the LCM is equals to 360.